In this video, we're going to have a look at straight line problems in context. We've got one problem to have a look at, and it has been taken from the national5maths.co.uk website, a really fantastic website. Okay, let's have a look at this problem. A taxi fare consists of a call-out charge of £1.80 plus a fixed cost per kilometre. A journey of 4 kilometres costs £4.60. Straight line graph shows the fare f pounds for a journey of d kilometres. Find the equation of the straight line. Okay, well, if we just try and understand what this graph is telling us here, it tells us that regardless of how far we travel, it will always cost £1.80. It will tell us that if the graph tells us that if we go 4 kilometres, that's going to cost £6.60. We want to find the equation of the straight line. Now, if we think back to straight line, there are two branches that we can use here to find the equation of the straight line. The first branch is y equals mx plus c. We would use that if we know the gradient and the y-intercept. The second branch is y minus b equals m bracket x minus a. We'll get two branches we could use here. This will always work, and this will work in certain conditions when we know the y-intercept. Let's have a look at our graph. Do you notice here that although it wouldn't make sense for there to be a negative journey, do you notice that that £1.80 is in fact the y-intercept? I know that in this case the y-intercept is £1.80. So it maybe makes sense to use this first form here. So it's going to be y equals mx plus £1.80. So all we need to do now is we need to work out the gradient. In order to work out the gradient, we need to work out the difference in the vertical over the difference in the horizontal. Let's take a note of our coordinates. So our coordinates were 0 along, £1.80 up, and the other coordinate was 4 kilometres cost £6.60. So to calculate our gradient, that is found by finding the difference of the y's over the difference of the x's. So x1, y1, x2, y2. So we can substitute this in. So the difference of the y's, £6.60 minus £1.80 over 4 minus nothing. That's going to be £5.60, that's £4.80 over 4. So the gradient, or 4.80 over 4. So the gradient is 1.20 or 1.2. So we can say that our equation is of the form y equals 1.2x plus 1.8. I'll leave off the units for the moment. But that would be if our equation was in terms of x and y. But it's represented differently here, so we want to have our equation in terms of d and f. So wherever I have got an x, I'm going to put d. Wherever I've got a y, I'm going to put f. So it's going to be f equals 1.2d plus 1.8. This is the equation of the straight line. And remember, it's important to actually understand what this means. So f corresponds to kilometres. No, it doesn't. Sorry, f corresponds to pounds. So this is saying, what this is actually communicating is, to work out the price, we do 1.2 multiplied by the distance in kilometres, then we add 1.8 or £1.80. Just a wee comment here. You could have absolutely got through this question by doing y minus b equals m bracket x minus a. Because if you've got your gradient, which is 1.2, and we're going y minus, we could choose one of these points. So maybe choose this point here. So maybe y minus 1.8 is equal to 1.2x minus 0. So that's going to be y is equal to 1.2x plus 1.8. We get the exact same both ways. I just wanted to make that clear. Okay, so generally we work through this in terms of x and y, and then we replace the letter. We replace with the letters that we're really working with. Okay, part B. Calculate the fare for a journey, that's the cost. calculate the cost of a journey of 7 kilometres. So we want to work out the cost when the journey is 7 kilometres. So this is just going to be a substitution. The cost is found by doing 1.2 multiplied by 7 plus 1.8. The cost is going to be £8.40 plus £1.80. So the cost of this journey is going to be £10.20. It's really important that when we've got like these in context, that we can kind of make sense of what the letters represent. And once we can do that, we can then substitute in and evaluate as normal. Okay, so it's the exact same as a straight line, it's just sometimes we've got different variables to consider that stand for different quantities. Thank you very much.